Hello, my name's Rocky Dazell. I'm with the American Public University System, and I'd like to talk today about the size advantages of the Starship Cargo vessel. I have a little project that might be able to challenge Starship, and we'll take a look at it as we go by. The first thing we do is take a look at the launch of SN-15. That's the one that went up, belly flopped, came down, and actually stood up on the landing. So that one is the one that actually made it back down, stood on its own hind feet. A little bit of fire only toasted toes and left her alive, left her intact. The rest of uh, the earlier versions of this machine were all destroyed on impact. But we're working on the next one, which puts a booster yay far underneath this thing, and we'll let this guy come down on its own. So what I'm looking for is size comparison. These rocket ships are 9 meters in diameter outside, and they are 8 meters inside. The cargo vessel is 9 meters across. The human-rated crewed vessel will be 2. The cargo vessel at 150 tons will carry, let me see, 9 meters from the shoulder straight down to the back of the cargo bay. Is 9 meters in diameter and 9 meters back. The rest of this is still cargo, except for maybe the top. I think the tip holds fuel and or oxygen. We'll find out. But the deal is, what we're going to the deal is we're going to put these mirrors from the Giant Magellan Telescope. Okay, so we're going to have to build our own. So that means we can fit them to actually go in there. The rest of the cargo is going to be for things like stock from the 3D printer, the 3D printers, Archinauts, and nuts and bolts to fit all 7 of them together. We're looking at 7 mirrors. I consider the fleet to be 7 starships plus a human-rated one, because we're going to take construction astronauts out there to put it together, and we might have a few spare seats for scientists and engineers. The Once we get out in there, we could pull the mirrors out, pull all of our stuffings out, and get the thing put together. This will be about mid-Earth orbit. This is probably on the other side of the Earth from Hubble, but we'll figure that out on the way by. That's details that we can design in once we need them. We need to get a look at the telescope itself. Now, this is pictorial of the way they're designing the Giant Magellan Telescope they're putting into the Atacama Desert down in Chile. 8.4 meters. Each one of these mirrors is in diameter. There are 7 of them, including the one in the middle that's got the hole in it for the focus beam from the secondary. That's it right there. The focal point, which is Gregorian, by the way, I'll leave that to you as an exercise to go look up. It's fascinating. So we get the mirrors out there, we get the thing built, bolted together, and we get ourselves this much of a mirror set up that looks like this. Our secondary out here, instead of being active active optics to deal with the Earth's atmospheric distortions, will not be needed because we'll be above the atmosphere. So all we're going to need out there is a simple secondary mirror set. There's 7 of those mirrors that are bouncing each one of these image sets back to the middle and into the focal point. In the back, we have something like 5 or 10 instrument sets. We're going to be looking at spectrographs, precision spectrographs, microspectrographs, and all kinds of instrumentation back here. The normal stuff you'd be putting into a nice big observatory. The structure you see down here, that's you might recognize it. It's just a standard old Dobson mount. You got your bearings here that are just floating in oil. Uh, not much of a bearing in oil. In fact, I think it's just a half a dozen molecules of oil thick. But it slithers. The thing is, at 500 tons, we don't need it to go into orbit with. We'll just leave it behind and put a few tons of gyroscopes underneath this thing to get it as good a point as we're going to need. The next thing we're going to have to do is find a way to get the permission, I guess. Maybe a little bit of funding put together. This, I think, because I'm leaving behind 2 major portions of the telescope, I can probably get it to come in under or very close to the budget that they have for the earthbound version, which is somewhere in the range of $2 billion. I'm thinking I can stay under that because I won't need adaptive optics. That's what these guys are for. These are your artificial stars to show the adaptive optics, how badly the Earth's atmosphere is twinkling the starlight, so that it can go back to the secondary mirror set and adjust those secondaries to match the adaptive optics. That's what that's all about. Expensive, fancy, not needed in outer space. Any questions?